Propylene oxide is an important chemical raw material. It is widely used in synthetic resins, latex paints, glues, and other products. This article will introduce the production process of propylene oxide. The main production process of propylene oxide is through an alkali-catalyzed oxidation reaction. The specific steps are as follows. First, the raw material preparation. The raw materials needed to produce propylene oxide mainly include propylene, hydrogen peroxide, alkali solution, etc. Propylene is the substrate of the alkali-catalyzed oxidation reaction. Hydrogen peroxide is the oxidant of the reaction. The alkali solution is used to catalyze the reaction and adjust the pH value of the reaction. Next is the reaction process. First, inject propylene and hydrogen peroxide into the reactor. Add an appropriate amount of alkali solution. There is a special catalyst in the reactor. The catalyst can accelerate the reaction process and increase the yield. During the reaction process, it is very important to control the temperature and pressure of the reaction. Generally speaking, the reaction temperature is between 40 to 60 degrees Celsius and the reaction pressure is between 0.5 to 1.5 MPa. The reaction time is generally short, ranging from a few hours to more than 10 hours. After the reaction is completed, the product obtained is propylene oxide. However, some byproducts and impurities will be produced in the reaction, which require further treatment. The most common treatment method is distillation. The reaction mixture is properly heating causes evaporation and condensation at different boiling points, thereby separating propylene oxide and obtaining a pure product. In the process of producing propylene oxide, another important factor to consider is safety. Since propylene and hydrogen peroxide are highly active, they are prone to explosion and combustion. Therefore, in production, it is necessary to strictly control the operating conditions and take corresponding safety measures. For example, explosion-proof equipment is installed on the reaction equipment to strictly control the temperature and pressure during the reaction. In addition to the above-mentioned epoxidation reaction process, there are other process routes that can produce propylene oxide. For example, propylene can be converted into propane through direct oxidation reaction, and then through oxidative cracking reaction to generate propylene oxide, or propylene can be obtained by catalytic cracking of propane, and then subsequent epoxidation reaction can be carried out. These process routes have their own advantages and disadvantages and can be selected according to actual needs and economic efficiency. In summary, the production process of propylene oxide is mainly completed through base-catalyzed epoxidation reaction, which is completed through raw material preparation, reaction process, and product treatment. In actual production, it is necessary to strictly control the operating conditions and take safety measures, while considering the economic and feasibility of the process.